Hello children, welcome to my maths notebook channel. Today I am going to show the problems based on chapter 1 real numbers, very important repeated questions in board exam. So I am going to show you the solutions of how many 7 important questions, repeated questions in every board exam of chapter 1 real numbers. Okay, class 10th solutions I am going to show here. I have written 7 important questions mostly asked in every exam. Use first question, what is this? See here children, use Euclid's division lemma to show that the square of any positive integer is either of form 3m or 3m plus 1 for some integer m. Okay, second question, what is this? Express each number as a product of its prime factors. Okay, given two important questions are there, that are 140 and 3825. Third question, what is given? Given that HCF, very important questions, HCF 306 and 657 is equal to 9. Find the LCM of these numbers. And fourth question is, prove that 3 plus 2 root 5 is irrational. We have to prove that the given number is irrational. Okay. And fifth one, the state whether the following rational number will have the terminating decimal expansion or non-terminating. We have to state. Okay, we have to show that the numbers are terminating or non-terminating. And sixth one is, what is the HCF of the smallest prime number and the smallest composite number. Okay, we have to find the HCF of smallest prime number and composite number. Find the HCF and LCM of 404 and 96 and verify that HCF and LCM is equal to product of the two given numbers. We have to find the HCF and LCM first. Okay, and also we have to verify that the product of HCF and LCM is the product of given two numbers. Okay, first of all we are going to solve one by one solution. Okay, so let us see first question. Solution I am writing directly here because here is the question. So without wasting the time, see here what we have to show. To show that the square of any positive integer is either of the form 3m or 3m plus 1 for some m. So we have to use the Euclid's division lemma. Division theorem we have to, with division algorithm theorem. Let us write the solution first. You can easily understand by this is the very easy quick revision for 10th class exam, board exam. So follow my answers children. See here, if you have completed your preparation, so this is the quick revision for prepared children, well prepared children. Okay, see here, let x be any positive integer. We have to take, let us take integer is, positive integer is x, and y is equal to what? 3 I am taking. Okay children, let us take x be a positive integer by Euclid's division algorithm. What is the division algorithm children? Remember the division algorithm. X equal to what we have to write? 3q plus r, because y equal to 3 and x is a positive integer. So we have to write by using division algorithm. What we have written here? X equal to 3q plus r. For some q greater than equal to 0 and r is equal to what? 0 1 2 3 so on, 0 1 2 3, as r is greater than 0 and r is less than 3, because y is equal to 3, so we have to take r less than 3. Okay, therefore x equal to 3q, we get, whenever substituting r equal to 0 we get 3q, r equal to 1 what you will get? 3q plus 1, and r equal to 2 we get 3q plus 2. Okay, Now as per the given question, if we take the square on both sides, because what we have to show here, square of any positive integer, so we have to take the one by one squaring on both sides. First I am taking x equal to 3q, squaring on both sides, what you will get, x square equal to 3q whole square, that is 9q square. We can also written it as 3 into 3 q square. Okay, so let us take 3q square is equal to m. Okay, then we get what, x square is equal to 3m. This is the first equation I am taking it as. Okay, now let us take x equal to 3q plus 1. Squaring on both sides, x square equal to 3q plus 1 whole square. Now what you will get, 3 square q square plus 1 plus 2 into 3q into 1. Then x square is equal to what, 9q square plus 1 plus 6q. Then common what, 3 common I am taking here. Okay, taking 3 common, what you will get, 3 common. After getting this one, we have to take out 3 common, 3q square plus 2q plus 1 here remaining constant. So I am taking this term as m. So 3m plus 1 we will get, x square equal to. This is the second equation. Now let us take third one, that is 3q plus 2. So x equal to, now x equal to 3q plus 2. Squaring on both sides, x square equal to 3q plus 2 whole square. Okay, what you will get, 3q square, 3 square plus 2 square plus 2 into 3q plus 2. This means 9q square plus 4 plus 6q plus 2 into 2. 12q. 3 2s are 6, 2s are 12. Okay, this is 12q. Now common we have to take 3. We get 3q square plus 4q and plus 1 we are getting here. 3 1s are 3, remaining 1. Then we get 4 as a constant. Okay, then this term is m. I am taking 3m plus 1. So this is third equation we have obtained here. X square is equal to, and here from 1 x square equal to 3m obtained here, and next second equation is x square equal to 3m plus 1 and x square equal to 3m plus 1. So like this we have obtained x square equal to what, 3m comma 3m plus 1 and 3m plus 1. So what we have obtained here, we have to prove that what, in the form of 3m or 3m plus 1 for some m. So hence we have the equations from 1 and 2. We conclude that the square of any positive integer is either of the form 3m or 3m plus 1 for some m. So like this we have to prove the, by using division algorithm theorem we have to prove like this. Taking first we have to take 3q plus r as a equation, as x is a positive integer and y equal to 3. Then by substituting r equal to 0, 1, 2 and r is less than 3, so we are taking 0, 1, 2. Then we get x equal to, substituting 0 here we get 3q, 1 3q plus 1. Whenever r is equal to 2 we get 3q plus 2. Squaring on both sides for every, after 1 by 1 we get 3 equations from this. Okay, so we get the proof that given square of any positive integer is either of the form 3m or 3m plus form 1. Next is express each number as a product of its prime factors. That is second one I am going to show here. Okay, let us do second problem as the product of its prime factors. Okay, now first one is 140 and 3825 is the second one. Second solution is, first one is 140. So what we have to do here? 140 we have to express it as product of its prime factors. We have to write that using the division of a number, by prime factors. We have to divide with prime factors only, because we asked to write the solution in the product of prime factors. Okay, prime numbers we have to divide. Prime numbers method, we can get the product of prime factors of 140. Okay, 140 is equal to, therefore 140 is equal to, we have to do LCM. Everyone knows how to divide this. By 2 we are going to divide. Prime factor, smallest prime factor is 2 here. 2 sevens are 0, 2 threes are 6, remaining 1, 1 2 5s are 10, and 5 here. 5 sevens are 7 ones are. So 2 into 2, 5 upon 7. So what we have? Prime factors, all are prime factors. So 140 is equal to 2 square into 5 into 7 is expressed as the product of prime factors. Next one is, second one, 3i25 is given. So we have to divide with prime factors here. 3i25, 2 ones are 2, 2 nines are 18. It will not go in 2, so I am taking here 3 here. Okay, 3 ones are 3, 3 twos are 6, 2 remaining here. 3 sevens are 21, 1 here. 3 fives are 15. Next, 3 fours are 12, 3 twos are 6, 3 fives are 15. Again what? 5, 5 eights are 40, 2 remaining, 5 fives are 25. 5 ones are 5, 35, 5 sevens are 35. Next, 17 ones are 17. Okay, the product is what? 3 into 3 into 5, 5 into 17, that is 3 square into 5 square into 17. We have written in the form of product of prime factors. Okay, like this we have to do the by using division of a number. Okay, next, given that, what is the next question, children? Given that HCF of 306, 657 is 9. Find the LCM of that numbers. Okay. Now, next, third question, very important question. Given that what? We have given HCF of 306, 657, children, is equal to 9. LCM is equal to, we have to find. Okay, LCM of same numbers we have to find. So solution, we have to, as we know we have to write the product of HCF and LCM is equal to product of numbers, product of given numbers. Okay, this is the form we know that formula, that HCF and product of HCF and LCM is equal to product of given numbers. So what right here? So we have what? We have HCF of 306, HCF into LCM, that is HCF into LCM is equal to 306. Numbers are 306 into 657, product of the numbers. What is HCF of the given numbers? 9 is given. 9 into LCM is equal to 306 into 657. LCM is equal to, this 9 becomes the divisor here. Multiplier becomes divisor of here. Okay. So what here? we have to multiply this one, 306 into 657, and we have to divide this 9. What we will get here? 3 3s are 9, 3 1s are 3, 0, 3 2s are 6. 3 1s are and 3 2s are 6. How much remaining? 3 1s are 3 and 2 is remaining 27. 3 9s are 27. 102 into 219 is coming here after dividing this cancellation. So product of 102 and 219 is 22338 is the LCM of given numbers. That is 306 comma 657. So like this we have to solve, children. Whenever HCF is given, LCM we can easily find. If LCM is given, we have to find HCF. Same formula we have to write, that is HCF and LCM is equal to product of given numbers. Okay, from this we can find out LCM and HCF also. So next fourth one is what, children? See, prove that 3 plus 2 root 5 is irrational. Okay, we have to prove that 3 plus 2 root 5 is irrational. Solution, fourth question. Prove that 3 plus 2 root 5 is irrational. I am writing here question. See again what is given here. Prove that. Solution here. See here, prove. We have to prove. Okay, let us take 3 plus root 2 root 5. 3 plus 2 root 5 be a rational number. Okay, if we get the conclude that this is wrong, then that number is irrational. So we are taking conversely, because irrational we have to prove. We are taking let it be a rational number. Let it be a rational number. 3 plus 2 root 5 be a rational number. Okay, we have to prove that it is not a rational number. Okay, then what we have, then the coprimes are x and y of the given number. I am taking x and y are the given coprimes of the given number, such that we have 3 plus 2 root 5 is equal to x by y. What we have taken? Rational number. So x and y are in the form of rational form. So what you will get? 2 root 5 is equal to x by y. This 3 comes to this side, minus 3 it becomes. Okay. Now root 5 is equal to what? X by y minus 3, 1 by 2. It comes to denominator, that is 1 by 2. Okay. Since we have x and y are integers, thus the obtained value 1 by 2 x by y minus 3 is a rational number, because we are taking 3 plus 2 root 5 is a rational number. Then this is also becomes a rational number only. Okay, but root 5 is also a rational number. Okay, this becomes rational number, then the value of this one root 5 is also a rational number. But this confirms that, but is not true. Confirms means root 5 is not a rational number. The fact that root 5 is not a rational number, it is irrational. Okay, so root 5 is a irrational number, then 3 plus root 5 is also a rational number. So our assumption, we have to write that our assumption is wrong, that 3 plus root 5 is not a rational number. So it is irrational. Okay, children, understood? Our assumption that 3 plus 2 root 5 is a rational number is wrong. Okay, that we are wrong. We have assumed that 3 plus 2 root 5 is wrong. So what it is? Hence we proved that this is very important question, children. 3 plus 2 root 5 is irrational. Okay, like this we have to prove. We have to take that it is rational number, and we have to prove step by step that is this is irrational, this is rational, and this becomes also rational. But root 5 is the irrational number. If root 5 is irrational, this becomes irrational. So our assumption irrational number is wrong. Like this we have to prove this question. Okay, next one, fifth question, that is what is state whether the following rational numbers will be terminating or non-terminating. Given two problems are given, 13 by and 14 by. What we have to do here, children? Next, that is fifth question. Fifth question is we have to prove that there are terminating or non-terminating. 13 by 3125. If you are well prepared of real numbers, you know the point that if the denominator has only factors of 2 and 5, that is in the form of 2m into 5n, then it is having terminating decimal points, terminating decimal expansion. Okay, if other than 2 and 5, then it has non-terminating. Okay, non-terminating, non-repeating. Okay, non-terminating decimal expansion. Okay, so this is important, children, very important points. If the product in the form of 2 power m and 5 power m, denominator, simply we have to remember this main points. Denominator is in the form of the product of 2 and 5, then we get terminating decimal expansion. Other than 2 and 5, then non-terminating. Here what denominator is 3125, then what we have to divide with prime numbers. 5 6 are 30, and 1 here, 5 2s are 1, 5 5s are 25. 5 again I am taking here, 5 1s are 5, 5 2s are 10, 5 5s are 25. 5 2s are 10, 5 5s are 25, and again 5 5s are. So 3125 denominator can be written as 5 into 5 into 5. 5 times it is repeated. So this is 5 power 5. This can be written in the product of 2 power 0 into 5 power 5. 2 power 0, a power 0 formula is 1 always, since we know that a power 0 equal to 1. Okay, so this can be written as in the form of product of 2 and 5. So what it has? Terminating decimal points. 13 by 3125 is having denominator in the form of 2 and 5. Denominator is in the form of, we have to write this step, children, so that your checking invigilator can clearly understand what you have written in the conclusion. Then the 13 by 3125 has a terminating decimal expansion. Like this we have to write the conclusion, children. Very important point we have to note in the solution. If we are forgetting this, we can't express this solution, we can't do this solution in your exams. Okay, decimal expansion. Okay, another I am going to show here. Next one, second one, what it is given, that is 64 by 455. 64 by 455. How we can show this is terminating or non-terminating? See here, children, another one I am showing here. 65. Take denominator, we have to express it as prime factors. 5 9s are 45, 5 1s are. Again 5 1s are 5, and 5 9s are 45, 5 1s are 5, 0 here. Again 7 1s are 7, And now next what we have to take, 7 1s are 7, 2, sorry, denominator is, since the denominator is in the form of what, we have to write in the form of 455 in the form of 2 power m and 5 power n, that is 5 1s are 5, 5 9s are 45, 5 1s are 5, again 7, 7 1s are 7 and 2 here remaining, 7 3s are 18 and 13 1s are 13. Okay, little confused I am here, putting 0 here. See here, 5 9s are 45, 5 1s are 1. So product what, denominator is 45, product is 5 into 7 into 13. It is not in the form of 2 power n and 5 power n. So what we have here, since the denominator is not in the form of what, denominator 455 is not in the form of, not in the form of product of 2 and 5, 2 power n and 5 power n. Therefore 64 by 455 has a non-repeating, non-terminating terminating decimal expansion. Okay children, like this we have to prove. Okay, next one, what, very important questions I am explaining you. Quick revision of first chapter, real numbers. Okay, very important questions. Next question, what here, 6 1, what is the HCF of the smallest prime number and smallest composite number is given. Okay, what is the HCF of the smallest, here we can easily do HCF of the smallest prime number, that is what, sixth one, that is HCF the smallest prime number is what children, 2, and the smallest composite number we are asked here, composite number we have to write here. This can be comes under in PYQs also children. So prime factorization of 2 is 2 only, and prime factorization of 4 is what, prime factorization of 4 is what, 2 into 2 prime numbers we have to write in the product of 2 prime. Then HCF of 2 comma 4 is what, 2 only. The common factor is 2 comma 4, that is the highest common factor of 2 and 4. Therefore HCF of smallest prime number and the smallest composite number is what, 2. 2 is the answer children. Very important question, it is asked in a PYQs, so remember this. Okay, last but not the least, that is what, HCF, find the HCF and find the HCF and LCM of 404 and 96, and we have to verify that HCF and LCM is equal to product of numbers we have to prove. Okay, this is given, we have to find HCF and LCM of these numbers and verification. So what children, very easy question, this will comes under 5 marks question also. So prime factorization of, first we have to find the prime factorization of 404 and prime factorization of 96. Okay, so this can be written as 2 into 2 into 101, and this is 2 in 2 power 5 into 3. Okay, HCF is 2 into 2 and that is 4, and LCM is 2 power 5 into 3 into 101, that is 9696 we will get. Okay, product of this total is 9696. So HCF and LCM is what? Product of numbers. We have to verify this one. HCF and LCM is what? 4 into 9696. That is what we will get after multiplication. 9696 4. 4 6 are 24. 4 9 are 36. 37 38. Okay, 4 6 are 24. 25 26 27 we will get. 4 9 are 36. 37 38. So 38784 is the HCF and LCM product. What we will get? We have to verify, children, given in the question, that is product of the numbers also values same. So we have to do product of numbers, that is product of 4 what 404 and 96. 404 and 96 also after multiplication you will get 38784. So hence verified that HCF and LCM is equal to product of 404 comma 96. Okay, like this we have to write. After writing the solution we have to write last step, that is hence verified, that is HCF and LCM is equal to product of the given numbers. First we have to find the HCF of the numbers and LCM of the given numbers. Okay, very easily we can find the HCF by using prime factorization. Okay, after that we have to verify the solution. Okay children, if you are not subscribed my channel, please subscribe my channel for more interesting videos of class 10th board exam maths, how to write maths exam. Also I have uploaded, children, please go through my channel for more interesting videos on maths. Okay, like, share and subscribe my channel for to your friends. YouTube website is @notebook maths and channel is maths notebook. Okay, very important maths channel, children. So go through my channel, subscribe my channel, please. Thank you for watching. Thank you. Bye bye.